Calculate the following sums. The sum from k equals 1 to 3 of the sum from m equals k to 3 of mk. B, the sum from I equals 51 to 100 of 2i minus 1. And C, the sum from j equals 4 to 99 of the square root of j minus the sum from j equals 6 to 101 of the square root of j minus 1. A, the sum from k is equal to 1 to 3 of the sum from m is equal to k to 3 of mk. Alright, well that looks really complicated, but let's understand it by writing down what it means. This first sum here means to put all the possible values of k into this formula here and then add up the answers. So we'll have k equals 1 and k equals 2 and k equals 3. And then we'll put all of those into the formula, so we'll have the sum from m is equal to k, but k is 1, to 3 of m times k, but k is 1. So that's the first one. Plus, and we'll put 2 into the formula, the sum from m is equal to k, but k is 2, to 3 of m times k, but k is 2, so that's 2m. Plus the sum from m is equal to k, but k is 3, up to 3, of m times k, but k is 3, so that's 3m. So that's what we've got. Okay, now let's deal with each of these sums separately. So this first one here is the sum from m equals 1 to m equals 3. So let's see. M equals 1, m equals 2, m equals 3, and we add up m. So m is 1, so we have 1, m is 2, so we have 2, m is 3, so we have 3. Okay, so that's the first sum. Let's have a look at the second sum now. The second sum is from m equals 2 to 3. So we have m equals 2, m equals 3. And the formula is 2m, so we'll have 2 times 2 and 2 times 3. Okay. So that's the second one. And now the third one is the sum from m equals 3 to 3 of 3m. So we have m equals 3, and that's the only option. So we put 3 into the formula, and we get, well, we can fit that in over here, plus 3 times 3. Just fit that in. So we add up all of those things, and that's the answer. So 1 plus 2 plus 3 is 6, plus 2 times 2, which is 4, so we're 10, plus 2 times 3, which is 6, so we're 16, plus 3 times 3, which is 9, so we're at 25. So this is equal to 25. So let's start a new page and do part B. B. The sum from I equals 51 to 100 of 2i minus 1. Alright, well, so what does this mean? Well, we'd do each of the possible values of I and we'd figure out the formula and see what we get. So we've got I equals 51 and I equals 52 and all the way up to I equals 100. And we've got 2 times I minus 1, so 2 times 51 minus 1. 2 times I minus 1, so 2 times 52 minus 1. 2 times I, so 2 times 100 minus 1. And then we'd add everything up like that. And that does not look helpful in the slightest. So maybe I'll do it a different way. So let's rub all of that out and try again. So maybe I need to use the rules that sums do in order to split this sum up into some easier sums to cope with. So let's see, this would be equal to the sum from I equals 51 to 100 of 2i minus the sum from I equals 51 to 100 of 1. Because sums, you can do each part of the sum separately. It's a little like expanding brackets. You can imagine this sum sign moving in next to both of these things. Okay, well I know that also the other thing I can do with sums is bring numbers like this out the front. So I could bring this 2 over here. So that would be equal to 2 times the sum from I equals 51 to 100 of I minus, and I haven't changed this bit yet, so I'll leave it the same. Now what? Well, we need to figure out what these two things are. We need to know this and this. Now there's actually a formula for this. So let's have a look at that. Well, there's kind of a formula. I'll write down the formula I've got from my book. So the sum from I equals 1 to n of I is equal to a half of n times n plus 1. Okay, so if I put n is equal to 100 there, I'll get the sum from I equals 1 to 100 would be equal to half of 100 times 101. So a half times 100 times 101, which would be equal to 50 times 101, which would be 5,050. Okay, but I haven't got the sum from 1 to 100. I've got, let's delete this one so we know which one we're talking about. I've got the sum from 51 to 100. Okay, well, the sum from 51 to 100, I suppose if I figured out the sum from 1 to 50 and took it off, that would give me the right answer. So I know what the sum from 1 to 50 is. That would be a half times 50 times 51, which using my calculator comes out to 1,275. And so let's think about this. We've got the sum from 1 to 50 and the sum from 1 to 100. So if we just want the numbers from 51 to 100, we take off all the numbers from 1 to 50 and that would give us the ones we want. So the sum from 51 to 100 would be 50/50 minus 1275, which would be equal to 3775. So we've dealt with this bit here. Now all we need to do is deal with this bit here. So let's write that down. The sum from I equals 51 to 100 of 1. Well, let's just write down what that means. We've got if I equals 51, I equals 52, and then all the way up to I equals 100, like that. And then we just put 1, and if I equals 52, it's 1. All the way up to if I equals 100, it's 1. So we're adding together a whole lot of ones. So if we just count how many of the ones we have, that would give us the answer. So we have from 51 up to 100 there. So that's 50 ones. So that's equal to 50. So now we should be able to figure out what our sum is. What I'll do is I will just put my 50 up here, so I've got a bit of space. So the sum from I equals 51 to 100 of 2I minus 1 is equal to 2 times 3775 minus 50, which is equal to, when I calculate it, 7500. One more try. So that's my answer. One last part to do. C. The sum from J is equal to 4 up to 99 of the square root of J minus the sum from J is equal to 6 up to 101 times the square root of J minus 1. Alright, well, let's just write down what each of these things mean and see if that helps. The sum from J is equal to 4 up to 99 of the square root of J. So we would have J equals 4 would be our first one. So we'd put square root of J, so square root of 4. And then we'd go all the way up to J equals 99. And so we'd do the square root of 99. Like that. Okay. Right. So the other one was J from 6 to 101 of the square root of J minus 1. So if J equals 6, we would put in the square root of 6 minus 1, which would be 5, plus, and then we'd go all the way up to J equals 101. So we'd have the square root of 101 minus 1, which would be the square of 100. Okay, so that's what my two sums are. And I want to do the top one minus the bottom one. Well, let me just put in a few extra terms. I'll just rub out this bit first. And give myself a bit more space. So I've got root 4 and root 5 would be the next one. Plus root 5 plus root 98 plus root 99. Okay, that's what that one is. And let me just make this next one a bit more expanded. So this one will go root 5 plus root 6 plus blah 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 plus root 99 plus root 100. I do the top one minus the bottom one. So let's see. Oh look, root 5 minus root 5, that would cancel out. And look, the root 99 minus the root 99 will cancel out. And the root 98 will cancel out with the root 98 that's here. And the root 6 that's here that will cancel out with this root 6 that's here. So all the middle ones are going to cancel out. And I'll just be left with the root 4 minus the root 100. Excellent. So the sum from j equals 4 to 99 of root j minus 1, of root j minus the sum from j equals 6 to 101 of root j minus 1 comes out to root 4 minus root 100, which is 2 minus 10, which is -8. And so that's my final